Hello everyone, welcome back to Math Verse by Vishal. So in my previous videos I have covered almost all the shifts of April sessions of JEE May 2026, right? Only two more shifts are remaining, that is 8th and 5th April, and that is also only on afternoon sessions. Okay. Now in this video I'm trying to bring the top 5 questions, pure advanced related questions which appeared in these two shifts here. So there are some good level questions which are definitely important for the upcoming JEE advanced session. So let's try to discuss those kind of questions in this video. Okay. And also moreover, the entire playlist of the April JEE main session is there in my channel. Go check it out. Let's take the first question. So this is one of the interesting question which appeared from binomial theorem in those sessions. So it is somewhat tricky question actually. Many students might have struggled with this. Let's see the trick behind this. First of all, you need to make few observations here. That is, when you take the entire series here and look at the binomial coefficients here, 12C2, 12C4, 12C6, and so on up to 12C12. So you can see that we do not have all the binomial coefficients, only the even bases are there. So whenever we have the even bases or also odd bases, immediately you have to recall the formulas of these. 1 plus x whole to the power of n plus 1 minus of x whole to the power of n, right? Because in this case, when you expand, what do you get? You get 2 times of nc0 plus nc2 into x square plus nc4 into x to the power of 4 and then so on, right? So you get even basis when you do this simplification here. Now in this case, since we have 12c r type, let's put n is equals to 12 in this one and try to see what happens. That is 1 plus x whole to the power of 12 plus 1 minus x whole to the power of 12 is equals to, it will be 2 times of 12c is 0, 12c2 into x square, similarly 12c4 into x to the power of 4 and then so on. Obviously the final term is going to be 12c12 into x to the power of 12. Okay, so let's take it as equation number 1 here. So this is the first observation that needs to be made in the question. Now look at the coefficients of the binomial terms here. If you look at the coefficient of 12c2, it is 2 cube. If you look at the coefficient of 12c4, it is 2 to the power of 5. But when you have 12c2 in our required equation number 1, look at that, 12c2, the coefficient is x square, but we need x cube. Okay, are you getting the trick here? In the required part, it is 2 cube into 12c2, but here in the equation 1 we have 12c2 into x square. So we need x cube but not x square. So obviously what we can do is we need to integrate here because 2 cube by 3 is just like x cube by 3. If you look at this 2 power 5 by 5, it is like x power 5 by 5, which means you can get this 2 cube by 3 by integrating x square. You can get this 2 power 5 by 5 by integrating x to the power of 4. So that is why I'm going to integrate this equation number 1 on both sides. Integration of 1 plus x whole to the power of 12 plus 1 minus x whole to the power of 12 of dx is equals to 12 times. So now let's start integrating here. You get 12c 0 into integration of 1 plus 12c2 into integration of x square and then so on up to finally 12c2 into integration of x to the power of 12. Okay, the main idea is to integrate on both sides. Now let's put the limits also for this one, that is lower and upper limits of this integration. Now as you can see, 2 cube, 2 power 5, 2 power 12, that is in the place of x we need 2. That is why what I'm going to do is I'm going to take the integration limits as 0 to 2. Okay, I hope you got the point why I'm taking 0 to 2, because in the required series we need 2 cube, 2 power 5 and so on, right? So in the place of x we are having 2. That's why integrate all the terms from 0 to 2. Now the remaining part is not a difficult thing. So let's see how to integrate this. Directly the integration of 1 plus x to the power of 12 is 1 plus x to the power of 13 divided by 13, where the limits are from 0 to 2. Plus similarly this is 1 minus x to the power of 13 divided by, I'm going to put minus 13 because for obvious reasons the coefficient of x is minus 1 there, right, while integrating the second term, and is equals to 2 times of, now this is direct one, that is 12c0 into integration of 1 will be x, so this will be limits 0 to 2. Similarly 12c2 into integration of x square is x cube divided by 3, and again limits are from 0 to 2. And then if you proceed in this way, the last term is going to be 12c12 multiplied by x to the power of 13 divided by 13, where limits are from 0 to 2. Okay. So this is your integration from 0 to 2. Now I think you understood the main logic here, because if you look at the right hand side part, this is 2 into 12c0 is 1, and x substituting 0 to 2 will give you 2 plus 12c2 multiplied by, when you put the limits here, this becomes 2 cube divided by 3, and next term obviously becomes 12c4 into 2 power 5 by 5, and then so on up. If you look at the last term, it is going to be 12c12 multiplied by 2 to the power of 13 divided by 13. Look at the required expression there. It is exactly the right hand side part except the first term. So which means you need this term here. In your required part, this is your series. Okay. Now I'm going to leave the calculation part to you, because what is the remaining calculation? Left hand side, substitute the limits, but along with that, you need to take this first term also to the left side, because this is the only required part except the first term. Rest everything is the required part. Okay. So as I told, this is how you need to get the idea of integration here when you notice the question like this, right? Okay. So this is a very tricky question, which is definitely important for coming JE advanced, right? Let's take the next question. I think this is the most difficult and also lengthy question which was asked in that paper. And this is a pure advanced type of question appeared from circles chapter. So let's see how to understand and interpret the questions like these. Okay. So there is a circle given to you basically. There is a circle. Center is clearly known to you, 3, comma 4. And then let AB is a variable chord of this one. AB is a variable chord of this one, and they said that this AB is subtending a right angle at the origin. So clearly origin is inside the circle because S11 is less than 0, and they are saying that this AB is making right angle at the origin here. Okay. So the most important thing that you need to notice in this question is this part here. The chord of this circle subtends a right angle at the origin. Okay, so whenever they are saying the line segment which is formed by the points of intersection of a curve and a straight line is forming some angle at the origin, then definitely it's a idea related to homogenization. Okay, most important idea. Whenever they are saying the line segment forming an angle, some angle theta at the origin, the immediate idea is to go for the homogenization process. Okay, but here we have the circle, but we don't have the straight line AB here, because if you want to homogenize this circle with this straight line, you need the straight line equation. Okay, so for that they gave one more information actually. Look at that. If the locus of foot of perpendicular drawn from origin to the chord AB is given by the equation, so which means you need to find out the locus of foot from origin to the chord AB here. So let me take it something like this here. And since I'm trying to find out the locus of this foot, let me take this point P as H comma K. Okay. Now the main idea is to construct the equation of AB here. For that, what we need to observe is I can get the slope of AB here. Okay. Because I can calculate the slope of OP first of all. What is slope of AP directly? Sorry, OP directly K divided by H. K minus 0 divided by H minus 0. If K by H is the slope of OP, since OP is perpendicular to AB, we have slope of AB is equals to minus of H by K. So we have the slope of the line, we have the point on the line also, and then you can write down the line equation, that is y minus K is equals to minus H by K multiplied by x minus of h, and now you can cross multiply, get everything to one side. You get hx plus ky is equals to k square plus h square. So this is your straight line equation. Now starts the process of homogenization. So I think you know very well how to homogenize. So you can divide by this k square plus h square and get this term hx plus ky divided by h square plus k square is equals to 1. Okay, and then you're going to homogenize the circle by using this straight line here, and we know very well we should not change anything about the second degree terms, but for the first degree terms you have to multiply it by 1, and that 1 should be replaced by this one, hx plus ky divided by h square plus k square. So directly I have taken that minus common, minus of 6x plus 8y, and for the first degree terms into 1. That is why hx plus ky divided by h square plus k square. And minus of 140 is also there, but since it is a constant term, you have to put 1 square, right? So finally what we get is hx plus ky divided by h square plus k square whole square is equals to 0. Okay. Now you're going to homogenize this. I mean, you're going to expand this completely and separate the terms. But what do we know about this homogenization process here? If that homogenization is done by the straight line, you are going to get the pair of lines OA, OB, right? That's the ultimate conclusion of homogenization. So whatever is this, this is representing equation that is the pair of lines OA and OB. Pair of lines OA. Clearly in the question they are saying that these lines OA and OB are perpendicular to each other. So whenever we have a pair of straight lines equation and they are perpendicular to each other, what's the condition? Obviously, we know that it should be coefficient of x square plus coefficient of y square is equals to 0. So this is the idea that you have to get. That is, just completely expand everything and try to separate the x square terms and y square terms, and then simply make the coefficient of x square plus y square is equals to 0. Okay, so let's see how we can do that. If you properly segregate the terms here, let's see what is the coefficient of x square. I'm not going to expand completely. Just by looking at the entire equation, I'm going to collect only the coefficients of x square. Okay. So coefficients of x square are 1, and then minus of 6h divided by h square plus k square, and then next minus 140 from the third term, 140 into h square divided by x square plus y square. This is coefficient of x square. And similarly, next I am going to take the coefficient of y square. Because of this y square term, I am going to get 1. And in the second term here, the coefficient of y square is going to be minus of 8k divided by h square plus k square. And what about the last term? I'm going to get it as minus 140 k square divided by h square plus k square. H square plus k square. So this is coefficient of x square and coefficient of y square. Now since they are perpendicular to each other, make the sum of these two is equals to 0. So if you do the sum of these two, you're going to get it like 2 minus of 6h divided by h square plus k square minus of 8k divided by h square plus k square minus, I think you can take directly 140 divided by h square plus k square common, right? And remaining part is going to be h square plus k square, and moreover this is actually h square plus k square whole square in the denominator, right? So I'm sorry about that. In the denominator it is the third time h square plus k square whole square. Okay, so if I take that common, minus 140 divided by h square plus k square whole square, the remaining part will be h square plus k square is equals to 0. Okay. Now you can do the simplification part because it is clearly 2 minus of, again if I take 1 by h square plus k square common here, you are going to get 6h plus 8k, and minus of one of the term will be cancelled out. You will be getting 140 divided by h square plus k square is equals to 0. Now you can simply take LCM, and finally what we get is 2 times of h square plus k square minus of 6h plus 8k minus 140 is equals to 0. Okay. And clearly, since you are supposed to find out the locus at last, replace h comma k with x comma y, and that's your locus equation. And compare it with whatever they have given, because they have given that the locus is this form. So compare this with whatever you have got, that's your locus, and finally get the value of alpha, beta, gamma. Okay. So as I told, definitely it is a lengthy question and also difficult to get the idea of homogenization. But if you understand this properly from here on, whenever we see this kind of questions, try to get the idea of homogenization. And since they are perpendicular, what's the condition? Coefficient of x square plus y square is equals to 0. Okay. Let us take the next question. This is a tricky question from sequence and series chapter which appeared in that shift, and many students might have struggled how to manipulate this question and convert into telescopic summation. Let's see the idea. It's a very standard question. Okay. So first thing you need to write on the general term for this one. So let us write on the general term here. PR is clearly is equals to R divided by 1 plus 4 R to the power of 4, right? So this is a simple idea many of you might have got already. And then obviously you need to express this as a sigma notation, that is sigma. We need 10 terms. R is equals to 1 to 10 TR, which is R divided by 1 plus 4 R to the power of 4. Okay. Now, obviously, it's a question based on telescopic summation, which means you need to express it as a Vn minus of Vn plus 1 or similar terms, right? So that for that thing, what I'm going to do is take this expression R divided by 4R power 4 plus 1. Now, the idea is to add and subtract a term, that is 4R power 4 plus 4R square plus 1, and then minus 4R square. That is, I'm trying to add and subtract the term 4R square. And then the obvious reason is what? I can express the first three terms in the denominator here as simply 2R square plus 1 whole square. Whereas this 4R square here is nothing but 2R whole square. So that the denominator is exactly in the form of a square minus b square. So directly it is going to be a plus b into a minus b. 2R square plus 2R plus 1 multiplied by 2R square minus 2R minus 2R plus 1. So this is your simplification part. And take it and substitute in the required sigma notation, that is sigma of R is equals to 1 to 10. And along with this one more thing is here the numerator has only R, right? But I'm going to rewrite it in this way. Observe carefully. I will be writing it as 2R square plus 2R plus 1 minus of 2R square minus 2R plus 1 whole divided by the same thing here, that is 2R square plus 2R plus 1 and so on. Okay. But the problem is what? In the numerator here, when everything gets cancelled, 4R will be remaining, but we need only R. So I'm going to divide by 4 here. Okay. So put it 1 by 4 because when you cancel out everything, numerator will have 4R remaining, but we need only R there. And then what is there? Directly take this and put it here, from which you're going to get sigma R is equals to 1 to 10. I'll take the 1 by 4 constant outside. And if you split the terms, clearly, first this 2R square plus 2R plus 1 will be cancelled out. Remaining part will be 1 divided by 2R square minus 2R plus 1 minus 1 divided by 2R square plus 2R plus 1. Okay. Now the idea is very clear. That is, I am going to take the first term as VR. If I take this as VR is equals to 1 divided by 2R square minus 2R plus 1. And if you properly calculate VR plus 1, if you look at that, 1 divided by 2 into R plus 1 whole square minus 2 into R plus 1 plus 1, you're going to get it as 1 divided by 2R square plus 2R and plus 1, which means the second term is exactly going to be VR plus 1. Okay, so that's the main observation here. If the first term is taken as VR, the second term is exactly becoming VR plus 1. So finally what we have is 1 by 4 into sigma R is equals to 1 to 10 VR minus of VR plus 1. Now you know what to do. Simply expand the telescopic summation. You will be getting something like this, right? V1 minus V2, V2 minus V3, and then so on up to what's the last term here? Directly it is V10 minus of V11. Everything will be cancelled out. Only the two terms will be remaining. That is 1 by 4 times of V1 minus of V11. Okay. Now you know what to do because you already have VR with you. This is your VR. If you have to calculate V1, put R is equal to 1. If you have to calculate V11, put R is equals to 11. And that is your final answer. Okay. So I'm leaving the calculation part to you. But look at the rearrangement, how we have converted a simple TR as using as in the form of telescopic summation method. Okay, so that is the main important part here. So these kind of questions are very frequently asked in BitSat and also at advanced also sometimes they'll ask, but they'll complicate it more. Okay. Let us take the next question. Now, this is a question based on both statistics and also binomial theorem. So, some students might have struggled to solve this question, and let's see how to tackle these kind of questions for the upcoming BITSAT and also advanced exams. So, first thing we need to recall the formula for mean of a frequency distribution. So, mean is equals to sigma xi into fi divided by sigma of fi. But very clearly, this is sigma fi, which is equals to nc0 plus nc1 plus nc2 so on up to ncn. Right? And this is a very well-known formula to us, which is directly 2 to the power of n. Okay. And moreover, this mean is already given to you, which is equals to 45, right? So let's put that in the mean formula sigma xi fi divided by 2 to the power of n is equals to 45. Okay. Now, more importantly, we need the value of sigma xi fi here. But there is a huge advantage in the question because if you look at the last term, directly you can notice a general term. Okay. So for xi, I can write down the general term as directly r into r plus 1. Okay. This is very clear. As per the last term only, we can tell that r into r plus 1. And what about the Fi general term NCR. So let me take these two general terms and put it here. So this implies sigma of xi is nothing but r into r plus 1 multiplied by fi is nothing but NCR. Okay. And also you need to know the starting and the lasting and like the lasting last terms, right? That is r values. So r is starting from 0 going up to n. That is r is equals to 0 to n and whole divided by 2 power n, and I'm going to cross multiply that, which will give me 2 power n into 45. Okay, now let us see how to simplify this one. So if I split the sigma here, this becomes sigma r is equals to 0 to n, r into r, which is r square multiplied by ncr. And what about the next term? Sigma r is equals to 0 to n, r into ncr, r into ncr, which should be is equals to 2 power n into 45. Okay. So, but the main thing you have to observe here is I can start the sigma directly from r is equals to 1 in both of these here. Okay, r is equal to 1 because what's the simple reason? If I put r is equal to 0, anyhow the first term is going to be 0, right? So let me start directly from r is equal to 1 itself. Okay, now the important manipulation part comes, that is sigma r is equals to 1 to n. This is r square, right? R square multiplied by, I'm going to write this as NCR, that is n by r into n minus 1c r minus 1. Similarly, in the second term also, sigma r is equals to 1 to n, r into NCR is n by r into n minus 1c r minus 1. So I can cancel this out r, here also I can cancel out one of the r, and then n is a constant with respect to the sigma here. If I take it outside, this becomes sigma n into sigma r is equals to 1 to n r multiplied by n minus 1c r minus 1. What about the second term? There also n is a constant. Sigma r is equals to 1 to n minus 1c r minus 1. But the second term is a very well-known term to us because if you expand this second sigma, what you are going to get directly? N minus 1 C0, n minus 1 C1, so on up to the last term is going to be n minus 1 C n minus 1, which is directly the formula for 2 to the power of n minus 1, right? So that part is simplified. So the only thing is left over for the first sigma. There also we can do some modifications because here we have r into n minus 1 c r minus 1, but I'm going to write it as r minus 1 plus 1. R minus 1 plus 1, that's a required manipulation because if you split the sigma again, in the first sigma r is equals to 1 to n, the first term is going to be r minus 1 multiplied by n minus 1 c r minus 1, r minus 1 multiplied by n minus 1 c r minus 1. And again there I am going to use the formula. It is nothing but n minus 1 divided by r minus 1 multiplied by n minus 2c r minus 2. Okay, so that this r minus 1 will be cancelled out. And the next term is directly simplified, right, which is n into 2 to the power of n minus 1. Okay, now you understood what's the reason behind that, right? This is n into sigma. This is r is equals to 2 to n. And clearly n minus 1 is a constant. I'm going to write it outside like this, n minus 1 multiplied by, now again it is remaining part n minus 2 c r minus 2 plus n into 2 to the power of n minus 1, that is given as what? 45 into 2 to the power of n. And also if you observe, I have changed the sigma from r is equals to 1 to r is equals to 2. Again, what is the reason? If I put r is equal to 1 here, anyhow it is going to be 0. That is why I'm going to change from r is equal to 1 to r is equals to 2. But once again, what's your observation? This entire sigma is simply the expansion of 2 to the power of n minus 2, just like the other one we have simplified. So finally, what we have is n into n minus 1 into 2 to the power of n minus 2 plus n into 2 to the power of n minus 1 is equals to 45 into 2 to the power of n. Now we have the simplified expression. So once we get the n value here, you can find out whatever they're asking in the question, be it median or anything else, right? So that is the simplification part here. Let's take the next question. This is not a difficult question, but definitely some students might have struggled to get the proper idea for this one. Definitely this kind of ideas will be important for upcoming BitSat and also advanced. Okay. So the main thing you need to notice here is, if I take the angles here, angle A as is x plus pi by 3 and angle B as x minus pi by 3, the main thing is A minus B. If you calculate A minus B, you are going to get it as pi by 3 plus pi by 3, which is 2 pi by 3. Okay. So once you get this idea, immediately you have to switch to the idea how to get the term 1 plus cot A cot B. Okay, because the required integration is involving a term like 1 plus cot A cot B. So where do you get this 1 plus cot A cot B value from? It's a part of formula of cot of A minus B, right? So that is what I'm going to use. Cot of A minus B is equals to, so what's our formula for that? 1 plus cot A cot B divided by cot B minus cot A, cot B minus of cot A. Okay. Now you try to express this 1 plus cot A cot B value. So directly we can say 1 plus cot A cot B should be is equals to cot B minus cot A multiplied by cot of A minus B. Okay. So let me take this and put it in the integration here. So finally what we get here is integration of pi by 6 to pi by 4. Now the required expression is 1 plus cot A cot B, but I am going to replace 1 plus cot A cot B with what? Cot of A minus B multiplied by cot B minus cot A, cot B minus cot A, and of dx here. What's the main advantage with this here? We know what is angle A minus B, right? So if angle A minus B here is 2 pi by 3, the remaining part is cot of 2 pi by 3. But what is cot of 2 pi by 3? Clearly it is in the second quadrant, right? So we know what the value is, minus of 1 by root 3. And the remaining part is only pi by 6 to pi by 4 cot of B. Cot of B here is cot of x minus pi by 3 minus of integration of pi by 6 to pi by 4 cot of x plus pi by 3 is cot A, right? And you know well what to do next, right? So this part, remaining part, you can simplify because these are simple integrations of cot x function. So integration of cot x function is directly ln of sin x, right? So directly you can write down minus 1 by root 3 times of ln of sin of x minus pi by 3, where limits are from pi by 6 to pi by 4. And similarly, minus of this is going to be the integration ln of sin of x plus pi by 3. Limits are from again pi by 6 to pi by 4. Okay. Now I'm going to leave the solving part to you because the only remaining thing is what? Substituting the limits and getting the value and comparing it with the required equation there. Okay. So the main thing, the idea here is to get the idea, that is 1 plus cot A cot B term can be obtained from the formula cot of A minus B, which is 1 plus cot A cot B divided by cot B minus of cot A. Okay. So this is the idea, right?